In this session, we'll discover how HyperMesh builds upon its industry-leading geometry and meshing tools for 2D structures. Firstly, we'll explore purpose-built workflows to help users prepare models for meshing using geometry simplification. We'll then follow that with editing and mid-surface extraction. We will then see how users can generate high-quality mesh using several meshing templates, as well as direct mid-meshing technology to streamline the workflow. Finally, we'll discuss how batch tools lets users generate models even quicker and shorten model build times. Simplifying geometry is an important part of the model build process, and HyperMesh has access to several tools to facilitate fast and accurate model simplification, whether working with surfaces or solids. In this case, we'll focus on a mid-surface part, and we'll look at how we can defeature some of these geometries prior to and after mid-surfacing. So on our geometry ribbon, we have defeature tools available, supported for both 2D geometry and 3D, and including automatic feature recognition to search for geometry features based on our search criteria. So I can very quickly find, highlight, and select features for removal, or select features manually for direct feature removal. Next, we can generate our mid-surface, and we can use a fully automated mid-surfacing tool. And HyperWorks will automatically decide what features to use. And within the mid-surfacing tool, we also have the ability, if we need to edit the resultant mid-surface and directly interact with the model to change the mid-surface behavior to achieve the exact geometry that we need. In this case, we're happy with the result. The resulting mid-surface can be further defeatured using the same defeaturing tools. In this case, I'll search for holes, and again, select the features for removal. We can also remove features such as cuts and edges from geometries. So I can select lines and very quickly defeature, remove, and extend the surfaces to remove our features. I can do the same with our fillets. We can also add and edit topology directly using the split tool, which has both interactive drag and drop split and access to a number of different tools to split with certain tools, such as planes, surfaces, and lines. In our case, we want to split the circle on the top, so I'll use the washer split command available in the split with lines tool, and then use the interactive tool to add in some perpendicular split lines. The stitch tool is also available to edit topology directly, again using drag and drop to simply take points and lines and stitch them to the appropriate geometry. So I can remove those adjacent points. So in a couple of minutes, we can defeature and split the geometry. Lastly, we just need to connect the geometry together along our rear edge. So I'll use the cross extend tool. Cross extend lets the user input a distance and then a set of surfaces, and it will project, split, and trim the geometry to connect it together. You can also use the stitch tool to attach these edges together just by drag and drop. So we're ready for meshing in a couple of minutes. To generate 2D meshes, we can enter the mesh ribbon and choose from our predefined 2D meshing templates. We'll start with general 2D mesh, but there's several templates available for different meshing workflows, such as CFD and rigid body meshing. Once we're in the general 2D mesh tool, we simply select the surfaces for meshing enter our mesh size, and also interact with the full array of settings within our burger menu, and then generate our mesh. HyperWorks will intelligently mark the elements that have failed our element quality checks, and we can directly interact with the mesh density along any of the geometry edges. We can also turn on automatic recognition of shared edges so that topology along shared pieces of topology is automatically selected, making it even easier to quickly change the density of multiple edges. And we can also select multiple edges and input directly the number of elements we need to ensure certain mesh around features. For any areas where the geometry is not as required, we can go back to the splitting tool and add in additional topology lines. So we might want to add a horizontal line across an edge, and HyperWorks will automatically remesh appropriately to suit the topology change. Using the same meshing tool, we can also remesh by selecting a set of elements, entering the mesh size, and re-meshing those features. And we can go in and edit those. So we can change the behavior of this face from a quads mesher to a mixed mesh in a couple of seconds. And that's our mesh done. As we've seen, the mid-surface workflows are really powerful, but for these more complicated geometries, such as this plastic pocket, the resultant mid-surface requires significant amount of work from the user side to repair and stitch. So we have a lot of open edges, areas that we need to stitch, split, delete, patch, and so on. And whilst it's perfectly possible, it's going to take me a long time. So for these more complicated use cases, HyperMesh has a tool called Midmesh. This is accessible on the mesh ribbon. We simply select the component that we want to midmesh, a target element size, and HyperMesh will work out the rest. So what mid-meshing does is generates a mid-plane of the geometry without the requirement for the mid-surface tool. So all of the mesh is directly created at the mid-plane without the 2D surface requirement. The tool is also multi-threaded, so we can generate complex mid-meshes very quickly. And it's going to save us significant time over the more traditional mid-surface approach. And what this is doing in the background and underlying the direct mid-mesh tool is FE geometry. So this is the concept of combining topology with mesh and allows CAD and mesh to exist in a single entity. This has a couple of massive time savings. So firstly, the tools that I've used so far, things like stitch and split, are all accessible for both CAD and for the FE. So if I split the CAD surface, the FE geometry will follow it. And also mesh selections are a lot easier. So selecting by surface becomes inherent in the fact that it exists as both CAD and FE. So I've shown stitch and split, but also tools like drag, extend, imprint, and ruled can all be used directly on FE geometry as well. After it's generated the mid-mesh, there is some dedicated workflows for mid-meshing available in the tool, such as the ability to repair and fill faces, the ability to create new mid-edges and edit the created topology. There's an align tool, so if I make any changes and I need to realign it with the 3D solid, then I can. And then finally, the inspect tool. And the inspect tool will identify and highlight common issues with mid-meshes and provide us with some automated tools to generate and repair those. So if we have a look at our resultant topology once it's completed, you'll see there's going to be a lot less work from my end to repair the resultant mid-mesh. All of the shared edges and free edges are in a better state for me to start from. There is a little bit of work for me to do, so I'll start by deleting some faces which it's created incorrectly, just in areas where I maybe want to ignore them. So there's this thin face here that I will delete, as well as some tiny faces here which have come from the geometry. So I'll remove those, and the same over here. So I just delete them, and all the topology will update. The free edges, shared edges, and non-manifold edges will all update. With this rib region, I might want to extend the rib to the end to stop it generating these small elements in here. And to do that, I can use the split tool, as I've used in the past. Choose my target face and my tool, which will be my plane. And I can very quickly split the face and add our new edge in. And I can also use the interactive split tool to remove edges that I don't want to have on the resultant topology. So I'll jump back to the Midmesh tool, and this time I'll remove my rib, and I'll create a new mid-edge. So this creates a new edge for the topology, and I can extend it all the way to the end, and then use the fill tool to fill our face. I can use the same tool just to select a bunch of faces and ask it to repair them, and this will remesh, correct the topology, and give me a nice, good quality mesh really quickly. Further up at the top, we can look at some of the other mid-mesh editing tools. And in this case, I'll focus on the Align tool. So what the Align tool lets us do is take the source mesh or FE geometry and then align it with a given guide. So I can select two guides, the outer face and the inner face, and ask it to realign the topology. And then again, I can use the split tool to remove unwanted edges. And then use the repair and fill tool to grab and remesh our given face to end up with the topology we need really quickly. This back edge we'll repair in a second with the inspect tool, but I wanted to show the ability to edit to the topology. So when it generates the mid-mesh, it will automatically ignore certain flat features to try and improve the flow of the mesh. But we have the option as a user to give it a dedicated imprint. So I can pick this washer imprint and ask it to pass that edge down into the FE geometry. So again, complete control over the resultant topology if we need it. And then lastly, we'll have a look at the inspect tool, where we can provide the source 3D, the mid-mesh, and then find our common, perform some common checks to repair and identify any areas of concern. So firstly, it will identify things like nodes which are off the mid-surface of the model, or the mid-plane of the model, and I can simply click these to repair them. Or I can ask it to fix all of those off-middle issues. It also does the same for solid edges. So I can identify on this back edge where we've got nodes which aren't sitting on the solid edge. Again, I can force those to be aligned just by clicking or by asking it to fix all if we need to. There's then things like out of edge, out of solid nodes, edges off solids, and any element centers which are off middle as well. So we can quickly isolate these, interrogate them. If they're round holes, we might ignore them, or we might ask it to fix them all automatically. So in a few minutes, we're able to go from a complex piece of CAD to a good quality mid-mesh with the full control over editing the topology and the resultant mesh. The last thing we might do is to map the thickness. So in order to quickly map the thickness from the solid to our mid-mesh, we have a map thickness tool where we provide the source solid model, the target mid-mesh, And in the options, we can choose how we map that property to the mesh. And again, in a couple of seconds, we will interpret the thickness directly from the 3D model onto the 2D mesh. And coloring by thickness will show the thickness variation from our model onto our mesh. We've also got full control over cleaning up our mesh. So I showed some of the mesh editing tools. What I'll show you now is some of the mesh cleanup tools. So in our case, we're taking our completed Midmesh model, which we've spent some time tidying up. And on the Elements ribbon, we have several tools to repair and identify areas that need to be addressed on our mesh. So I'll start by entering the Edit Elements tool. And I'll also turn on element quality coloring. So hopefully you'll see that the areas of concern on the model have been highlighted. So there's some areas that need addressing. So there's elements which are color-coded, and these are color-coded based on our criteria file. So the criteria file dictates the element quality requirements that we have and gives us the ability to color those on the model, identify them, and also correct for them very easily. Using the Edit Element tool, we have a manual way of repairing the model. So I'll show you several of these. So first of all, density. If we want to change the density of any of the edges to update the mesh flow, then we can. And there's the Move tool. The Move tool lets us either click and drag an element or double click a point, and it will move the node or the element to achieve certain element quality. So in this case, we might want to manually drag or double click to clean up an element. Up at the top, we can use the Replace tool. So the Replace tool lets us replace nodes with each other. So I can take a node and collapse it onto a certain area and destroy the element in between. I can also get it to replace at midpoint if I need to try and preserve some of the expected topology. And we can also use the Split tool to split the mesh either graphically just by clicking on an element or using a drawn graphical line. So if I know that I want to split a certain direction down the model, then I can. It's also possible to create elements and delete them. So I could select a set of elements and remove them. Create an element by selecting the appropriate nodes, or as we did before, replace them to collapse the edge. You can also use the create element to try and fill this hole here. And I will remove these. And then use the create element just to add back in the elements that I want. So using the Edit Elements tool, we can manually generate and repair areas of the model that need to be fixed. So really powerful. What might save us a bit of time is if we can do some of these common things automatically, like moving nodes to optimize element quality, collapsing edges. So the Auto Quality tool lets us provide HyperMesh with a set of elements. It will isolate the areas that need to be repaired, and the Auto Quality tool will go and do a lot of the processes automatically to repair those trias and those quads. So now I've got 0 failed elements just by using the Auto Quality tool. What if I want to change the mesh a little bit more significantly? So I can use something called Rebuild, which lets me provide a parameter and criteria file to generate a completely new mesh based on a provided candidate mesh. In our case, the parameter file that I'll load is a file for a 5mm crass mesh. What the parameter file includes is average element size and type, as well as some special handling for geometry features. And the criteria file contains the target element quality requirements, which the rebuild tool will use to try and ensure that the elements that are created during rebuild pass our quality checks. So the rebuild lets me supply the elements, rebuild, and it will use our parameter and criteria file to generate our new mesh. The power of the rebuild is that we can add new geometry features such as our washer splits around the holes, and also try and ensure a better mesh flow across geometries as well. So in a couple of seconds we can completely rebuild and regenerate new topology features directly from our mesh. And then again we can just rerun auto quality to repair the model. So we've seen how powerful and flexible HyperMesh can be to give users full control over the detailed meshing and modeling with our tools. But to take advantage of these more efficiently, HyperMesh has also embedded these tools in batch that automates a lot of these common and repetitive tasks. So I'm going to start with the geometry on the screen. And some of the common things we've seen are things like suppressing edges, imprinting washers, those kind of things. So on the geometry ribbon, under D feature, we have a batch defeature tool called batch repair. And what batch repair does is uses those parameter and criteria files we've discussed in order to clean the model up, ready for our target element size. So if my target element size in this case is 5mm, then I provide a parameter file with a 5mm target size, and then also control things like the output options. So I'm going to ask it to clean up geometry. On the geometry cleanup side, we can ask it to fix certain geometry features within a certain tolerance, and also do things like hole recognition. So for now, I'll turn hole recognition off and use that later. But we provide the surfaces, we ask it to auto clean up, and in a couple of seconds, it will process the geometry and do the necessary cleanup. So in our case, it's suppressing edges in areas of flat features, suppressing areas which are edges which are close to each other, especially closer than our target element size. And that means that the resultant geometry is ready for our meshing without the need for me to manually clean up and edit a lot of the mesh. So that's ready for 2D meshing if we wanted to. In our case, I'll take it a step further. I'll undo the batch cleanup and go straight to the batch meshing tool. So in batch mesher, again, we provide a parameter and criteria file, but we also allow it to generate the mesh as part of the process. So in this case, I'm going to turn on hole recognition. Hole recognition is really powerful because what it lets us do is look through the model, identify holes, slots, and rectangular holes and square holes, ellipses, and any other mixed holes, and then treat it in a certain way. So in my case, I'm going to remove any holes smaller than 2.2 mil radius. And then for the rest, up to 20 mil holes, I'm going to imprint or treat the mesh in a certain way around that hole. So for 3 mil holes, I'm going to want 4 elements. For any larger holes, I want to make sure that there's at least 8 elements around the hole. And we do the same again. I provide it with the surfaces, ask it to mesh, and this will do the two things. It will firstly generate my simplified geometry, so it will do the edge suppression and everything that we've looked at. And then it will generate our mesh using the batch mesher. Our batch mesher uses the parameter and criteria files just like the rebuild. So again, we get good mesh quality flow, and it uses the mesh criteria to ensure that the resultant elements are going to pass the checks that are required. So this might take a few seconds just to generate. We also have Batch Mesh available through a standalone tool, and this processes multiple input CAD files automatically and in parallel. And we'll see how we can use this later in some of the model build workflows. Once completed, we'll see we're not only able to suppress those edges, but also the washer treatment around the holes has been performed. And if I quickly take a look at our mesh quality, we reduce the number of failed elements significantly, with 0 failing in our case on this particular geometry. So that brings us to the end of this session. We've looked at geometry simplification, so how we can quickly remove unnecessary details and features from the CAD. We extracted our Midsurface using the Midsurface tools and showed how they could be completely automated with also manual control. We looked at 2D meshing, how we can interactively generate and adjust a high quality mesh. Or for complex geometries, use direct mid-meshing to directly extract the mid-plane mesh without the need for the mid-surface. We showed you cleanup, so the ability to identify, isolate and repair problematic mesh either manually or completely automated. And then finally, we looked at the batch processing tools available to either prepare geometry ready for manual meshing or to completely automate the geometry simplification and meshing process using our out-of-the-box tools. Thank you.